Dr. Friedmann, Mr. S.K. Negi, Mr. Mukherjee, and the moderator for the session, Mr. Amol, Kotwal. May now introduce to you Mr. Amol Kotwal, the moderator for this panel discussion. He is the Director of Energy and Environmental Practice at Sullivan. He and his team of consultants focus on monitoring and analyzing emerging trends, technologies and market dynamics across segments covering power generation, T&D, renewable, environment, building technologies, backup power, etc. for the region. Besides leading consultant teams for client engagement fulfillment in the region, Amol drives and coordinates research activity for the business unit. May now hand over the session to Mr. Amol Kotwal.
Thank you, sir, for the kind introduction. Good afternoon, ladies and gentlemen, and a very warm welcome to the T&D conclave here. The green energy is the buzzword today, and if you see the backdrop here today, you see a lot of green color. And in today's context, when we refer to India as a country where we have been plagued with energy shortage, power deficit, and dependency, a huge dependency on the fossil fuels. In that context, green energy or so-called renewable energy plays a very, very important role for us. And having said that, we are also aware of the advantages of renewable energy in Indian context. And in the backdrop of the huge ambitious target that the government has set for renewable energy capacity expansion in the country, specifically from to a cumulative target to close to 175 gigawatt in the next 7 years. It is very important to understand as to how the role of renewable energy will pan out and change the landscape of the power sector in India. And it is my privilege to be a part of this forum, and I thank the IMA organizing committee to Sullivan to allow us and to moderate this panel discussion especially. And it is my privilege again to moderate the panel where we have our esteemed panelists, industry veterans and sector experts. So essentially, when we're talking about this panel discussion focusing on challenges with respect to integrating renewable energy into the grid, we have a mix of eminent panelists, Mr. S.K. Negi and gentlemen, Mr. Sugata, bringing the perspective from the utility side as to what are the challenges and what are the best practices that need to be followed. Mr. Gideon Friedmann brings to throw some insights in terms of the his expertise on the technologies and what is it that can benefit in the Indian context in terms of integrating renewable energy into the grid. And obviously, Mr. Venu will share his insights and perspectives on the storage technology, because when you're talking about large-scale renewable energy technology being integrated into the grid, it also warrants the need for a huge amount of storage capacity, because at the end of the day, for example, we talk about solar and wind. There is a lot. It depends on a lot of weather conditions, the sunlight, and typically what happens is this kind of energy may not be available, and there's peak demand that is typically in the Indian context in the evening. So having said that, I would first like to invite respected Sir Mr. S.K. Negi. Mr. S.K. Negi is the Managing Director of Gujrat Energy Transmission Corporation Limited. He holds the membership of many professional institutes like Institute of Engineers, Expert Committee on GIS Manual, Power Engineers Society, New Delhi, Lead Auditor Certificate from QI. Mr. Negi started off from NTPC Power Grid as a senior manager in construction design and engineering of PHP substations. Moving on to Alstom India as the general manager, and further on to Reliance Energy as additional vice president in project planning and contract management. I welcome Mr. Negi to the dais.
Thank you, Mr. Kotwal. Good morning to all of you. Time given is 10 minutes, so I will try to do justice in that. It is quite an interesting and subject these days to talk about the RE, and I would like to give some of the experiences of the state, which reflects almost all the issues which are there related to renewable energy and how we have to tackle them. There are some presentation from substitute energy storage, and which will talk about balancing system and technology. So they will be discussing about that. So any operation issue we can delve it after my presentation. My presentation will cover mainly over the RE capacity in Gujrat, then how we do the data integration, what are challenges we face, and how we do the data integration of the RE successfully in Gujrat, so that each developer knows that what is producing, and as well as SLDC to tackle the variation uncertainty of the renewable energy and how they operate the grid with the wind being quite an unpredictable energy. And then some of the pilot projects were done. I will share some experience of that quickly and expectation for way forward. This is the one what we visualize. Not much has been done in India on, let me tell you frankly, on renewable energy integration, though we are talking for the last 3 to 4 years. I wish such conferences which is happening, taken by IMA, we take it forward. So coming to the Gujrat, just currently I will tell you that today we have 3,800 of wind and about 1,000 megawatt of the solar. So we were pioneer in implementing solar in India. We did Jalka, and subsequently also we have put up a lot of capacity. At one time we were actually more than 80% was in Gujrat, but today I am happy many states have taken lead, and still with this total energy of 4,800, which is nearly 20% of the installed capacity of generation, and we face tremendous amount of issues, and which we will debate now. So this is a just to give you a feel that why it's not coming. So this map, why I am showing this map to you is just to tell you that, share with you that this renewable energy is mostly on the coastal areas with the particular wind, and strategically there will be such location where the local demand may not be there. So being a local demand, then transfer this power to the place where there is load. This is a suboptimal utilization of those transmission lines, because the PLF of this renewable energy is hardly 20%. So that is the one challenge for utility. That is how they sometimes, when we talk about renewable energy integration, the utility is not able to put heart and soul in the development of transmission, because this transmission is only for this solar, wind and solar, which are far remote locations, and they will be sub-utilized. So this is one challenge also, developing a transmission system for that. But nevertheless, Gujrat has developed time to time gradually, and we have always maintained the status of must-run status. We have not denied anybody even for the shutdown of their plants anytime. So, and similarly, solar also you find that this yellow figure is all orange, and one of the biggest star is the Star Solar Park, which is having 370 megawatt in one place. And for that we are developing a 400 kV, 220 kV as well as 6 kV transmission system, so that no point of time there is a disappointment any time that this because of the transmission line there is a constraint. Coming to challenges, these are some of the charts to show you that the variation in the when we talk of my utility, so as I said 3,800, so we get a peak about 66 to 70% of that, means about 2,500, 2,600 we will be getting peak time during July, August and September monsoon season. So now in that 2,500, this energy comes all of a sudden, and you see this, my pointer is there. So this you see 24 hours graph is given to you, how from the small quantum it goes to the larger of 2,000, 2,500 megawatt. Similarly, solar is not an issue, because it starts in the morning, and then by the peak will be in the afternoon, and then Okay. So and similarly the case with solar, generally it's flat. We have tried to show you some of the cloudy time of graphs, so that tells us that solar also is having variability. And switch is here, it is comes down and ramps up, and the whole day it is 24-hour chart. So during that time, issue is that during this time, what we have now suddenly it comes to the, suppose it goes from the 500 megawatt to 2000 megawatt, so 1500 variation. If we, most of the time our units are 200 megawatt, so we have to handle, our operator SLC has to handle about 6 to 7 units. Practically has to shut down, but they don't shut down, they operate on technical minimum, because conventional plants are once they are shut off, then it takes its own time. So we have to run technical minimum. The casualty is the state government power plant. So what happens, this is inefficient operation of the power plant. This is the biggest weakness of the renewable energy, particularly wind, is that it has an impact on the conventional generation plants operation and the commercial loss to them. These are some of charts we have given for last 5 years to you, to show you that 14 and 15, some of the charts, and it clearly shows that, and these are the two peaks we got, this 2,400 out of 3,800 and this 2,300. So these are some of the maximum we got so far. There was a day when Gujrat was served, 1/3 of the energy was served in Gujrat by renewable energy. That also day we have seen. So we have to be alert from all these things. And another great change which through a data we are showing you that the 1000 megawatt variation in a day, sorry. Okay. We have here I have shown you that even in a single day, not single day, in a year, number of days in 12-13, there was a 60 days, there was a variation of 1000 megawatt in a single day, and like that we have captured that of 13-14 and then 14-15. So gradually this is increasing. See, in the 14-15 it has become a 94 days, and more than 500 megawatt variation. It has happened 257 days in a year. So this is kind of challenge one has to face the load dispatch system operator to handle the conventional generation and allow renewable energy, which has a much more strategy to operate. This is also a typical chart. I want to show you that when there is low demand, there is winter, monsoon season, we have a low demand. Okay, it goes to as low as 7,000 to 8,000 megawatt. Our general requirement is about 12,000 megawatt in the state. When the wind is 8,000 megawatt, and when we don't want this power is available. So this is peak is in the monsoon. So there is another tragedy, we have to handle it. Similarly, the case in Tamil Nadu, other states also. Even Tamil Nadu has got 2 to 3 seasons of the peak wind. So they have more challenge than us. Similarly, in October there is a high demand. Then this wind in Gujrat is in the low. So we have captured the chart of 3 to 4 years, and the pattern is same. So it is very clear that we all have to be ready when handling the renewable energy, that in the month of June, July, when the demand is low and the wind is peak, how we will have to counter it by what are the various means, ways and means. Similarly, when the demand is high, okay, and demand is high, wind is not there, it's not an issue, we will handle it by other things. But sometimes suddenly, all of a sudden, October, November also, sometimes it comes on weak, so we will have to handle that. And so after discussing these issues, these are some of the things, variable, intermittent, uncertain. Then there is a reactive power, because the wind machines will operate now and then because of the, sometimes it will be generating more, so comes down. So these are some of the reactive power issues are there. Then DSM violation, this I think I will not discuss here. It is a violation which Gujrat state does with respect to the load scheduling which we have done for the central power. So we regularly get notice from the grid operator, central grid operator, that we are violating that norms, because when the wind is peak, it goes suddenly, all of a sudden it comes from 500 to 2,000 megawatt. So in that position we will be in underdrawing position, means there will be excess in the grid. My convention is as well as the wind. So in both the cases I will be above the schedule, so we will be underdrawing. So this underdraw is a plenty in the Indian system, Indian grid operation. So that is another big issue. And then forecasting, I think this is the answer to many of the issues which I have been discussing now. then mandatory order. See, I will show you some of the cases when 1 rupee 55 paisa power is stepped down and wind is allowed to reach 4 rupees 13 paisa state, which we have to allow in the grid. Similarly, this impacting the conventional plant, which I have told you that they have to run on technical minimum, then network adequacy, so that many times there is a network adequacy. My own network, when the peak is there of 2500, in those areas it will not be able to serve that. So, but the biggest issue among all this, what I said, is the must-run status. We just cannot allow this windmills and solar plant to be shut down, because as per regulation, we have been asked to honor that. So this is another some data I have given you, that how much violation we have done. I think I will skip that. This is the graph which shows the red curve is the actually power which you are catching, and this another one, the green is the wind, which is fluctuates. Now this wind has gone in this day, it has from the bottom, it has gone to the up, and then see accordingly, this is the curve, and then we violate the under tall position. You see, accordingly, this graph is clearly can be understood, and then you see this shutting down, lowest rate backing down. 1 rupee 50 paisa, which I was telling, we have to do it, and we are given the data also on how many number of blocks it has happened on a particular day. So now, what is the answer to that? So how we have handled? We have not we have honored that, but the first and foremost thing for all of us was to ensure that the entire, which is actually lacking in many of the states, and that's grid operator first of all has to know what is going on in the grid, how much renewable has come. Earlier quantum is okay, but today quantum has gone to 3,800, and when peak is 2,400, which I has shown. So when it comes so much variation, 257 days for 500 megawatt, and I showed 95 days in a year for more than 1,000 megawatts. So the first and foremost thing for all of us is that my grid operator must know what is actually getting generation. So that is the first thing we did, and with solar data integration we have done through the radio link. This is I will not explain much because time shortage is there. So this is very successfully we have done it with the radio links, all the capturing of the solar data. Even the Charaka solar park, any solar developer, he can see any day in SLDC. I request all of you also, any day you visit, you will find what is going on in Gujrat in wind and solar. Is total summation of the entire state. It will be visible to you on any time, of running on online. It's available, and then so they have a clear knowledge of what is to my operator as well as to developer what is going on. And similarly in wind, we have done a 100% data integration through various technology. We have used the GSM, GPRS, we have lease line, PLCC, all put together we use, because it's very difficult to lay OPGW and have a reliable system. So mixture of communication technology we could achieve that, and this is the diagram which shows how we have linked to most of the things. And then the point is data capture. The second point was to have a proper forecasting. And unfortunately, none of the developers in India are very forthcoming, and they are not very positive in this respect that they are doing the forecasting. So we have lost our heart totally, and finally one mechanism was also introduced, but that mechanism was suspended by CRC. So what I want to say, this is the one thing we all have to do.
Negi, can I interrupt you? Last 2 minutes, please, because we are running more time.
I promise you. Then what we have done is we have done some of the we have taken initiative with this forecasting model, and our experiences are that when the wind is good, at that time that variation, the predictability is better. When wind is low season, so it is going as the mistakes are going as high as 50% to 80%. But when the wind is high and the predictability is somewhere in the range of 30 to 40%, this data shows. So now we have to improve upon this technology, that how in low wind condition also we are able to do a better accuracy. And to that extent, we have awarded one contract now to one company. It is a full-fledged contract. I think another 6 months we will be doing that. This was the pilot project. Now we have awarded the full-fledged contract. We will be improve upon the experiences what we have gained in the pilot project. Way forward, I think many people discuss. First of all, is that we should have an energy management center. it will be a part of the SLDC, and we felt that there is a need of a renewable energy management center exclusive for each state, and they should have it. They will capture the data. They will submit. They will take care of the all technological part of that, the data capturing, forecasting, and all that. And second one is RF mechanism. Third is balancing mechanism that I think my fellow speakers will discuss on this balancing, what is to be done. For me, the low-hanging fruit is the pump storage system which are available in the country. We should fully exploit them. Majority of them are not working in the country, so we have to exploit that. And then energy storage system which compressed hydrogen was discussed today. I think this is another technology which has been talking, but I don't know, out of many of the technology, we have to take a call on that, or government or various companies who can make these equipments. We have to decide on that. Then spinning, it is very important that to handle this, we should have a spinning reserve. See, earlier gas was costly. Fortunately, for the last 6 months, gas prices have come down. So now we will be happy to handle this energy variation. Otherwise, it was very difficult for us to go. Gas plants were though available maximum Gujrat. We have paid 1,000 crore as a fixed cost without using them. But today, I think this will help us. The gas prices come down. So we should have a spinning in the form of either gas or pump storage. The last one is the market mechanism. I think there has been a thrust by the regulator that there should be RPO, renewable portfolio obligation should be there. But unfortunately, many states in India have not followed that. For that, they can buy the certificate. But that also did not, has not been successful. So I think somewhere RPO fulfillment has to be thrust upon from all level, regulator, government. Once it is there, I think the renewable energy will be affordable, and it will be cost will come down and all the things, and then only this new technology will develop, and then with storage system or we can balancing mechanism, we can discuss regional wise, all those things will take place. Thank you very much.
Thank you, Mr. Negi, for that insightful presentation, and specifically talking about some of the practices that GETCO has been following in terms of integrating renewable energy in the state of Gujrat, especially given the fact that Gujrat has been at the forefront of specifically solar installations in the country. I would now like to invite Mr. Sugata Mukherjee, who is the head of solar and new business in that Tata Power Delhi Distribution Limited. His topic of presentation is going to focus on practices and solutions adopted to address challenges of for renewable energy integration from distribution utility. Quick background about Mr. Sugata Mukherjee. He has more than 2 decades of experience in 2 leading power discoms, CESC and TPDL, that is Tata Power Delhi Distribution. He's been a member of the core strategic team involved in the successful turnaround of Tata Power Delhi Distribution Limited. He has also spearheaded the solar initiative of TPDDL, and it would be good to hear about from him in terms of some of the practices, specifically when it comes to rooftop, which is in terms of the capacity a much more lower capacity in terms of the huge wind or wind connected solar plants that we were referred to. Over to Mr. Sugata Mukherjee, and you will have exactly 7 minutes because we are running late, and you want to. The other panelists will also present. So I would sincerely request you to finish in 7 to 8 minutes max.
Thank you, Mr. Kotwal, and very good afternoon to all. I am representing, as Mr. Kotwal has mentioned, that I am representing a leading distribution company in the country, Tata Power Delhi Distribution Limited. And I'll try to adhere to the timelines because 7 minutes is too short to discuss this kind of issue. But we will try to manage that time. As you know, all of us are aware that the good news is that solar projects are progressing rapidly in our country. From 5% in 2006, that share has been now increased, and we are also going ahead in full steam. But the concern is, as Mr. Negi has mentioned, the major concern is the variability as well as uncertainty of the renewable energy. It is a nightmare for the system operator. Some of them call it a terrorist thing because of the master status as well as the uncertainty of that. But I would like to cover in my presentation a different thing. I would like to cover the integration of the renewable energy projects with the entire system of the power distribution, because it's not only the transmission utility and system operators nightmare, but also the distribution utility has to take care of these things, as well as the overall system perspective. We need to see that, because power distribution is a societal issue also. So I'll try to quickly go through the presentation. This is some of the background slide. I think you can skip that. The good news that I was mentioning, that cost of the solar pack projects are reducing rapidly, as it has been reflected in the CRC generic tariff as well. Why grid connected rooftop? Because as all of us are aware that grid connected rooftop is the focus for the majority of the policymakers as well as the industry as well. 40 gigawatt has been made as a target, revised target for rooftop solar against the total target of 100 gigawatt. So that's a huge, but the grid connected rooftop has many advantages. As for the nation and as for the consumers, we are aware about that. For the DISCOM also, it has a huge advantage of managing the demand through the distributed energy resources. Particularly for DISCOMs like us in Delhi, we do not have the energy resources in our control, like unlike other states. We don't have much generating plants in Delhi, but the distributed energy resources can act for the management of the demand as well as reduction of the T&D loss, because in our country T&D loss is very high for all the distribution utilities, around 30%. So this will definitely be a big boost for the reduction of the T&D loss as well. This is the renewable energy growth plan. From this you can see that this is integration of the renewable energy can be a big concern in the coming years, because in the 13th plan the target has been made for 18.9% of the total share of the renewable energy, and in UN Charter again we have committed, our country has committed for non-fossil fuel, 40% of the energy should come from the non-fossil fuel. Just a broad difference for the DISCOM side, where we are talking about the DISCOM's role, the renewable energy integration related, the metering is the major thing. And there are two kinds of metering, gross metering and net metering. Today net metering is much more advantageous for the consumer because of the more economic viability, because consumer has to pay for the solar projects, and it will be for the self-consumption of electricity. So it has much more economical viable considering the financial health of the DISCOM in the country. This is a net metering based solar system. I will skip this slide because of the time constraint. Now coming to the impact on the peak demand for the distribution company. If you see the solar energy generation curve, it starts from the morning and it reaches the peak in the afternoon. And the afternoon peak demand in our country is increasing rapidly because of the urbanization and the industrialization of the country. So that way, the impact of the solar demand, if you can see that almost 80% of the solar generation is in the normal hour. If you consider a time of different day tariff for the consumers as well, the normal hour and the peak hour, we are getting 80% of the solar generation. For DISCOM, the major reason for promoting the solar is reduction in the afternoon demand. RPO obligation, we all are aware about that. Most of the regulators in the country has already mandated for the renewable power purchase obligation. Although enforcement of that is a big issue, as Mr. Negi has rightly mentioned. But RPO obligation meeting will be definitely a priority for the DISCOM in the coming days. Thirdly, for the urban areas, the DISCOM has also another issue, the congestion of the network. So for that, the distributed solar generation will help a lot to the DISCOMs. There are two main classes of the benefit for the DISCOM in this. One is avoided energy, because the solar generation, whatever will be the solar generation unit, that will be the avoided energy. And secondly, it is the avoided capacity of the fixed cost, because when solar generation is happening, it is reducing the afternoon peak demand, and it will also help the DISCOM to reduce their operation and maintenance cost, reduce the capacity enhancement for the distribution network, and that those are the fixed costs which can be reduced for the through the solar generation. Now, if we see the this reduction in the capacity will be depending on the coincidence of the energy peak and the solar generation. We have done a study in Kotwal Delhi distribution. We have conducted a study through E3 consultancy, and the study has been sponsored by USTDA. Here we have projected that what can be the solar generation in 2025 and how the impact will happen on the peak demand for the distribution utility. As you can see, that if the solar generation was not there, the distribution utility peak demand would be the other curve, which is on the yellow. But with the solar generation, projected solar generation, the peak demand can reduce. Although it is again showing that the evening peak demand is not getting impacted. The night peak demand or evening peak demand, what you can say for the summer. So that way the capacity of the distribution utility and the benefit for the peak demand reduction will be limited for solar. These are the few challenges which have been mentioned by Mr. Negi also, and the variability and uncertainty for the distribution utility. It has the impact on the supply, load, as well as the network. So the solution for that can be the other distributed energy resources. Other distributed energy resources are those are the initiatives which I can say, the demand response and energy efficiency. Professor has mentioned in the first session that the demand response and the energy efficiency should be the key in the future and we also think in the similar light. Other distributed energy resources for demand response, energy efficiency, we have already taken certain initiatives in TPDDL area. I'll share a few of the slides for that. But the analysis that we have made for the diverse distributed energy resources portfolio, we have analyzed the economical payback period for the solar generation and the solar generation clubbed with energy efficiency, demand response and grid storage. Now, for the second option, it is always a much higher payback. Almost the payback period is less, almost 2 years less than the solar generation alone. So we are focusing in these areas, and I believe the other utilities in the country would also follow the similar thought process in this. Certain status of the current automated demand response project in TPDDL area. I will just take 2 more minutes and finish it. So you can say that we have just done a pilot without any benefit to the consumers, but we have been able to achieve 7.2 MVA peak demand saving through the demand response. We have done a valuation framework for the solar energy regulatory program development. As I was mentioning, that we need to see the societal cost for the solar energy along with the other distributed energy resources, and we are always finding that the overall benefit is more than the overall cost for the project developer, consumer, all together. Some glimpses of TPDDL solar journey. We have started our solar journey in 2008, where today 15 solar plants installed in our own distribution area, and 2 megawatt of solar projects have been installed in our consumer sites. So what we have done, we have also through this study assessed the capacity, rooftop solar capacity on our area, about 400 megawatt rooftop solar capacity is within our licensed area of 500 square kilometer. We have created a model for facilitating the solar projects for our consumers, which is similar model is now being followed by the MNRE also. MNRE is also has advised the other DISCOMs or the state utilities for empaneling the agency for facilitating the solar projects. We have done that, and through that there is a huge cost and benefit as well as the quality has been ensured. Some of the monitoring mechanism we have implemented for our consumers. All the solar plants have been integrated with the GIS system, outage management system, and advanced demand management system in our area. We have started online monitoring of generation. Today it is only through the AMI, but we are also planning to have smart meter to be installed for the solar projects for both the generation as well as the net metering side, so that we can have a better online monitoring system. System protection as well as safety is also some of the concern which we have addressed. We have created a solar project awareness for our consumers through different awareness campaigns, and I don't know whether it is visible for the top photograph. It is poster has been created by one of our industrial welfare associations. They have mentioned that the solar conference has been for the benefit of the industry, where TPDDL will help them to reduce their electricity bill, which I believe that a big certificate for us. This is our vision for integrating the solar and the other renewable energy and distributed energy resources, the virtual power plants, with a smart grid. I believe the remaining question we can answer in the Q&A session. Thank you very much.
Thank you very much. Interesting to know about what TTDPL is doing, and having heard the perspective from the utility side, both Transco as well as DISCOM. And when we are talking about renewable energy, specifically both solar and wind, what plays an important role is the storage perspective, and that is where I would like to invite on stage Mr. Venu. He's the President and Head of Power's Division for ABB South Asia. And Mr. Venu is going to focus on large capacity energy storage and how this plays an important role for integration of renewable energy within the grid. Just a quick introduction again, Mr. Venu is the President and Head of ABB's Power Division for South Asia. He is also a member of the Corporate Management Committee of ABB in India. Mr. Venu's more than 2 decades of tenure at ABB has included several leadership positions in functional roles like sales, marketing, key account management, business development, channel management, customer relations, and operations. Mr. Venu is an active member of various professional bodies such as EMA and CII, and he also serves on the infrastructure committee of the CII and has been an executive committee member representing the southern region for CII's Power Conference. Welcome, Mr. Venu, and over to you.
Thank you, Amol. The topic given to me was energy storage, and 10 minutes, right, Amol? Yes, 8 minutes, okay. Good afternoon, ladies and gentlemen, and my respected co-panelists. What I do now is that before we talk about the storage, let me just talk about how the grid is evolving and which way to go. You can see my extreme right. It's called a super grid, where we want to connect the nations, like how we had one nation, one grid, like that we're connecting the nations, connecting the continents. It's a super grid, and maybe we call it as a Chinese viewpoint. And you generate the power here and then transmit the power over a distance of thousands of kilometers, let's say Africa, and build the power in between, and then start injecting the power on the way wherever you generate. So that's a one way, that's a super grid, the Chinese way. And on my left is the other viewpoint, is a totally contradicting viewpoint. Basically talks about a nanogrid, or microgrids and the nanogrids. You can see the picture is Elon Musk, who's imagining that every house basically is on the generator, and then transmit and then distribute and then consume, and you also store in the same house, and that's where is the thing. And when you combine together in the houses, then it will call its own grid impact. So the two extreme viewpoints, one nanogrid, which is, we call it an American viewpoint, and the Chinese viewpoint. But over a period of time, as we are going, more and more the renewables are getting injected into the grid, there will be a common path in between, and that's where we need to find out how that looks like. While we are looking at which way to grow on the grid structure, we also need to see how the renewable integration is happening globally. You can just see that this is the annual renewable share as a percentage of total generation, not on the percentage based on installed capacity. Today in Germany is around, well, while we speak, there are around 30% of the total generation comes from the renewable energy sources. And they're expected to go over 50% in 2040. And same is the case with India. Not to that extent, but today we are low, but then we are expected to go to almost close to 35–40% in 2040. Also see the dotted curve, which is nothing but a coal, how it's coming down over the years, which is right now is close to 40% and coming down, less than 20% in that. So this is a kind of paradigm shift, and it's all happening in that. This is all based on the data, and the real-time data is all happening in this. And how do we ensure when this kind of renewables, such a large quantity is getting into the grid, how do we ensure that the grid is stable, grid is reliable, and grid really we are in a better position to control the grid. And this also making a big shift in the electrical value chain, not only on the transmission side. We just talked about almost 40%, almost 50% of global generation comes from the renewable by 2040. And that's the way, and that gives, as my previous panelists talked about, it gives a lot of volatility, a lot of unpredictability, and we can't predict what time, how much energy is coming out in that. And that puts the pressure, increased pressure on the transmission and the distribution side of that. And we are talking about the more feed-in. It's not need not be that conventional grid always you have a one feed-in and then you have multiple feeding out of the points. But today we have more feeding points. That puts all the more important how can we control and how can we transmit the power in that. And this also talks about, as we talked in my first slide, of the nanogrids. And that's the biggest thing is you generate in a distributed way and then transmit, generate and transmit, and that makes the battery energy storage. That is the key. The fundamental key element of this is this storage. So why we are not, we are really, frog leap jump we took, talking about, solar. In fact, our visionary, Mr. Uma Shankar, is sitting here, who took this frog leap jump of the solar, talking about 100 gigawatt of that. When we're talking about how did we think? We were talking about when 20 gigawatts, 20 gigawatts we came to 400 gigawatts, and there we need to also look at the storage is also come in the same way. But what's the big bottleneck? Why are we not doing it? Is a big bottleneck at this point of time is clearly the economics. It's not viable. The projects are not viable at the prices what we have now in that. And we are not looking at a mega scale battery energy storage system at this point of time. But it's already happening across the world and including in India. So next two slides basically talk about, there is a clear parallel between what happened in the PV technology a few years back to what's happening in the lithium ion now. The lithium ion is predominantly the battery energy storage being used in the same. You just see that, the percentage increase of lithium ion, especially in electrical vehicles and the storage energy, which is just over less than 2% a few years back, 2010 and gone, is now has gone up to 15%. Same is the case, the silicon, which is a fundamental thing used in the photovoltaic, was less than 20% not very long ago. Today, almost 90% of the silicon produced is used for the solar PV. You can just see the parallel between these two things. And same is the case, you also see how the prices of the topmost chart was the prices of PV, how it's fallen. Every time the production is doubled in the PV, the prices have fallen by 24%. Every time the production is doubled, the prices have fallen by 20%. If you see in the last 40 odd years, 99% of PV has dropped. And you can exactly see you can draw the similarity in this lithium ion. Every time the production is doubled, the prices of lithium ion is falling by 20%. And that's where it's helping to expand the production. That's where it is helping to expand the production. So, the big thing, the next big thing in the power sector landscape is definitely going to be the storage. We're talking about 50% globally of the renewable, and that's where is the key that the big thing will be definitely the storage. So what are the drivers? There are many drivers. The drivers are environment is a key. We have also committed in committing to reduce our CO2. The offshoot of that commitment is 100 gigawatt of solar plant. Everything linked up. We have made a commitment to reduce, and the commitment is also we need to produce more solar in that. And the people quality of life. We still, after 50 years of independence, almost 1/3 of people do not have access to electricity. There are many places not possible to extend the grid in a conventional way. We need to have these microgrids, nanogrids. Combination of that will be the driver to go to the energy storage. We'll skip the industry trend for a paucity of time, but talk about the grid challenge. We already talked about intermediate, stochastic feeds. We just can't, not able to, even though there is intermediate, you can always predict, what time of thing. But with this solar, you never, so with the renewable energy as a whole, whether it's a solar or wind, unable to predict any trajectory, any pattern. That puts a lot of pressure on that. But the good part is that there are several technologies available. The technology is also evolving it. Whether you want to go for a super grid, or whether you want to go to nano grid, the technologies are evolving. The more we increase the protection, and the better the prices will come down in that. For example, interconnection. We also know there are a lot of interconnections happening in Europe, connecting between the nations, but through HVDC, through both subsea cable and surface cable. Flexible generation, flexible demand, and the energy storage. They are the key for the next big thing to happen in the power sector. My last slide. I know Amol will look at the time, and this is just an example of we have done where with 1 megawatt battery energy storage is a grid connected with very containerized solutions, ABB storage system with a 1 megawatt inverter and a lithium-ion battery used in a containerized thing. So before we end, I think battery storage will definitely expedite the renewable integration in a much better way, much more faster, and much more resilient, much more agile way. Also, the grid stability is very, very crucial, and that's where the battery storage will come into picture in that. And flexibility of supply, allows faster response time, and enables seamless switching. So that's all from my side, and thank you. Thank you, Amol.
Thank you for reviewing the storage space and specifically its importance when we are referring to the integration of renewable energy into the grid in the Indian context per se. Having said so, the next panel essentially having focused on the utility perspective, the importance of storage, I would like to now invite on stage Dr. Gideon Friedmann. He's the manager for Technologies and Renewable Energy section and coming from the Ministry of National Infrastructures, Energy and Water Resources from Israel. Obviously a country which is very well known for technology development. And his topic of presentation is going to be on technologies and related experiences in the area of renewable energy integration. A short, brief introduction about Dr. Gideon Friedmann. He has over 15 years of industry experience in semiconductor metrology, medical instrumentation, and biotechnology. His areas of expertise include renewable energy policy and pricing, electricity markets, smart grid smart distributed grid and grid security. From an education standpoint, Dr. Friedmann has a PhD in physics from Stanford University, a bachelor's degree in mathematics and physics from Tel Aviv University in Israel, and he also holds a diploma in bioinformatics. I welcome Dr. Gideon Friedmann onto the dais to present his views and thoughts.
Thank you very much for inviting me. Very kind introduction. My talk is rather an overview. I thought it would be nice at the beginning, but maybe it's a good summary also for this section. We have seen all of our speakers go into specific details of various problems and some solutions to the issues of the integration of the renewables into the grid. I will start. There are basically two main issues with the integration of the renewables, of the variable renewables. One is, of course, the problem of the variability, and we've seen a lot of data from our previous speakers. I would like to make a little bit of an order in this issue. There are several time scales on which the variability has to be dealt. First of all is the short term in minutes. Here I actually also mentioned that there is an even shorter term variability in terms of seconds, because for example wind can be variable depending on the size of the turbine, can have variability on even lower scales, and also the solar illumination can change on the scale of seconds. However, I think that the regulation needs to take care of that by forcing the local power station to deal with a very, very short variability, and it's possible there's no, technology is already here. So the problem today is the variability in minutes. And then there is also the long term. I would like us not to forget it, because we have dealt mainly with the short term, but what is long term is days. Okay, if we have our solar power and all of a sudden we have 1 week or 2 weeks, even with no sun, we still need to provide the power. And although we don't have storage today, we do not even envision that the storage will give us a solution on the long term of days, or weeks even, in some places. So this needs to be taken care of as well, and we should not forget it. In terms of the short-term management, I've seen that India is very deeply involved in trying to solve this issue. We already know that the management is possible. We have some countries where the penetration of renewables is very high. We have variable renewables. We have in Denmark about even close to 50%. We have in Germany around 20% of variable renewables. So we know that it's possible to solve it, except that we do it, the way we do it today is not efficient enough. It has caused the prices of the electricity in those countries where there is high penetration to go up considerably. So the one way that we can deal with this variability, again, I would like to separate it into two parts. One is what I call the common mode, when something is changing slowly in a trend, like if we have clouds coming in, or going out, then it's a trend. For this, we need the prediction, the weather predictions, and there's a fierce competition actually. I don't know if I can skip. There's very fierce competition in this field. I will mention a few solutions from Israeli companies which are, I think, interesting. One is called Meteorologic. It's a meteorological solution which is based not only on meteorological information but also on big data, on analysis of just the history, essentially, of the weather, so it's not only dependent on the meteorology. And another small company that is doing something like that is called Energy Lightning. In terms of wind short term, there is a company called Pentalum, which has a LIDAR, a laser sensing technology, which can sense the wind from a few hundred meters before the wind turbine, and so it can give a prediction if a wind gust is coming and one can rotate the wings of the wind turbine a little bit to adjust for that and give a more stable output. Pentalume is also doing, you can use the solution, the LIDAR solution, to measure winds at high altitudes at very low cost. Oops, sorry. I'm trying to return. With respect to, I would like also to with respect to the variability, we have seen solution talk about the storage. I would like to remind you that there is a traditional storage solution for traditional fossil or thermal-based energy, which could be, at least for the next 10 or 20 years, until we have all the more advanced solutions in place. There is a solution which is heat storage. Heat storage can help make the fossil industry, the fossil generation, more flexible. For example, if we have heat storage in a cogeneration, where we use the heat and the electricity power, we can use the heat in a much more sensible way and distribute it as it's needed. We can, in a combined cycle turbine, gas turbine, where there's two stages, the gas turbine and then the steam cycle. A gas turbine today is not very flexible. It has to run at a fixed, give the output. But if we have heat storage attached to the steam cycle, we can get very, very good flexibility of the system. So, in fact, for a short-term solution, before we get the batteries, even the largest ones today, we're talking about a few tens of megawatts, and this is really tremendous. But a power plant can be hundreds of megawatts heat-based electricity generation. And Israel also has a very, I think, very interesting solution for heat storage, which could make, in addition to what I mentioned, make the coal power plants a little bit more efficient in the use of heat, especially old plants. The company is called Renewable Energy. It has a modular heat storage going from about even 100 kilowatts to many tens of megawatts. So I think this could be a very interesting solution for storage. The second aspect is not the time problem, not the variability, but the distribution. Okay, one more thing. I will say one word about the long term. We've seen it in the information before. We have a problem that the variability over the year is tremendous. For example, this information from Germany shows that the lowest in 2012, the worst day in terms of production of wind and solar was 30 gigawatt hour during the day, and the best one was 530 out of their consumption, which is around 1,500 gigawatt hours. So this is such a tremendous difference. Today we don't have a good solution for that. We have to have the overcapacity of the fossil and electricity generation. And I don't know, perhaps the hydrogen storage will solve this one day, but it's not going to be easy even for that day. If we need to store hydrogen for a couple of weeks, it's going to be very challenging, I think. So they distributed, the fact that it's distributed also requires us to change our electricity generation, transmission and distribution system from the traditional, which went from a few power plants and distributed the energy to all the consumers, to something that has many, many nodes in the network. I would like to point in India, I think it's very important, that the renewable energy revolution makes the energy accessible to everyone. So it has a social impact, which I think is important as well. If before only the giants could produce electricity in large plants, today everyone can make electricity, everyone. It has not only energy, but it has a social impact. I think it's very important for a large country with a huge population. So the smart grid is, of course, the future of the grid with the distributed generation. I will not go into details here. Let me continue and mention the relation between the renewable energy and smart grid. Of course, the variability is an issue, but on a local basis, it's even more of an issue. So if we have a large system and we have clouds coming in, winds going out and all of that, it averages out. This is also the experience. The larger the system, the less variability issue we have. However, because the system is actually also has local content to it, the variability issue locally can be a much bigger problem that needs to be addressed by local management, not only sort of a system management. We've seen we need this storage, of course, demand-side management. I would like to say that we need to put the emphasis, I think, on demand-side management. This is a fruit that is available today. I believe this can be a much better solution, again, for the short term. Instead of storage, it can also give answers locally, not only system-wide, and it's relatively easy to implement, and which we should go ahead and do this, and all of this has to be done automatically. So the system has to be structured in a way that all the demand response is done automatically. I think it's not very close for every person's home to connect it to the general system, but if you concentrate on the big consumers, for example, a shopping mall or an industrial center, they already have today the management system, the energy management system, and it's just a matter of communicating to the center or the local center and do this the short-term flexibility. The customer should not feel that, and it should be in a few years. We are going to do some pilots on this in Israel pretty soon. Generally, I believe because when the problems are very difficult, it's good to take them apart. I think the microgrid is a good way to start in the management of the variability issue. And the microgrid basically is a small grid where we have some consumers, we have some production of electricity, and we have potentially storage as well. And we need to learn how to manage this more efficiently than we've done in the past. Everything has to be automatic. I think the future is very close in microgrid, even if this is being tried everywhere in the world now. We are also starting with this. We are going to have a pilot. It's a pilot started this year in Kibbutz. This is like a small town, and there will be more pilots over this year. If any company in India is interested in participating in providing solutions, that I welcome that you can talk to me. We will issue a bid in the next couple of months. And in that, I finish. Thank you very much.